Welcome back to another video. Aidan here from Bespoke Coachworks. In this video we'll be doing the lower quarter panel, as well as later on I'll do some TIG welding on some aluminium. We'll weld the front section of the guard to the rear section and sort of smooth it all out. So start off with, like always, we started with our paper pattern for this piece. It's not the biggest piece and it hasn't got a lot going on, so it's a fairly basic paper pattern. In our paper pattern we always like trying to collect our piece size as well as the panel information. When I speak of panel information, I'm talking about highlight lines, shrink, stretch, things like that. So in this panel, it just has a little bit of stretching along the top edge and the lower edge, and that's about it really. So not a lot to gather. So start off with, we're going to go into the linear stretch on the power hammer, and I'm using a 24-inch upper radius, and the lower is the linear stretch die. So the purpose of the linear stretch die is to spread the metal apart. So it's like I've got a contact surface of about 25 mil, and it's just like sort of a long, sort of straight, like flat line across the die, and I'm just ironing across the panel to sort of evenly spread the panel in the beginning, just starting to create that reverse curve. So with a reverse curve, you always want to make the outer edges longer than the inner edges, than the inner section of the material, and that's how we create a reverse. So what I'm doing here, I've got a little bit of like pre-tension in my hands to sort of help the panel take that arc, and then I'm just ironing along the panel, releasing those edges to try and make it happen. With a panel like this, the reverse isn't very severe, so you need to be mindful on how fast this happens. You've really got to work the panel evenly. You can't be going and doing too much in one area, because as you move through the rest of the panel, it might want to pull your reverse too hard. So it just takes a lot of sort of back and forth, ironing along the whole piece, quick check on the car, and then go again. It's just, yeah, you don't want to overwork it. A piece like this could be done purely on the English wheel, by stretching with a high pressure just on the outer edges. I like the controllability of the power hammer, being able to sort of hit it exactly where you need to. I don't really have a sort of preference between hammer or wheel. For me, it's just working on whatever machine does the job the best. And for me, the power hammer is the best for creating a lot of extra material through like linear stretch. So once again, just working through, ironing it out. Sometimes in areas I need to do a little bit more, I might sort of really sort of hammer the edge, try and create that extra material, and then I'll sort of work inbound from the edge to try and tighten it all back up. So I've just ducked over to do a quick check on the car. I didn't drag the camera around with me to do any test fits, because it's more just checking if I've got, because the panel is so I guess basic, it's really just checking that I've got that sweep, and that's it. So yeah, working through. So the panel at the moment is upside down, so I'm using a radius die on the top to create that curve. But you can already see how much it is getting there. It's not too far away from moving on to the English wheel, I'd say. One of the beautiful things about a power hammer is that you don't always have to work side to side like I am right there, and then I'm going in the opposite direction. So you can work sort of longitudinally as well as latitudinally. It's quite handy to sort of be able to do both. And that's the same as if you had radius dies in the lower. You can sort of work any direction, where with an English wheel you're always working the one direction without obviously having to rotate the panel. But with a power hammer, you can sort of be a little bit more random with it. You can sort of go exactly, where you need to. You can sort of work in a circle. You can work, edge to edge, or you can work sort of back the other direction. It doesn't really matter. Sort of like a comfortability thing, really, I guess. Just when you're working on a power hammer, it's sort of where you're most comfortable. With the English wheel, you really got to be set up and try and get that, be comfortable so you can actually work the material. So moving on to the wheel, we've got a reverse curve, so we've got to be very mindful in how you work a reverse curve on the wheel. So if you think you've got a flat upper, you need to have your panel wheeling on you need to have a slight angle when you wheel, particularly a reverse curve, not to get shoulders like the top outer edges of your wheel to damage, put lines in your panel. So you need to be mindful of the angle that you roll through. A good test, if you're ever doing it, is to just get your panel and put very light pressure on there, and sort of just like put the panel in there and then rotate it, like get your eyes down to level and rotate the panel through, and you'll see that flat spot, and that's the direction that you need to be wheeling. If I need to do that if I need to do a reverse curve, next I will try and do a demonstration on what I'm talking about there. But it's a very helpful thing just to, like, you witness it, and then you know that what it is, what did I mean by that. But yeah, basically you're just trying to find the flattest path through the wheel. From memory, I think I've got a 24-inch in the lower radius. A little bit more stretching, so just linear stretching across that edge. Coming into wheel, long ways across the panel now. A little bit of stretching along the edge. Now, you need to be thoughtful again when wheeling in general, but particularly in wheeling a reverse curve, just to understand what's going to happen to the material when you wheel it each direction. So if I wheel it that way, when it's working with the shape is sort of going over the lower wheel, it's actually going to straighten my panel. As the panel curls around the lower anvil more, it's going to straighten the long radius on my panel. So you need to be mindful on your pressure and things like that, and then how the material is going to change with each direction that you wheel it. As you wheel it more on an angle back towards the other way, the panel's going to flatten out and curl back the opposite direction. So it's just trying to find that balance between the directions that you wheel the panel. So yeah, just something to think about whenever you are working a reverse curve. This one is got more of a radius in one section than the other. So the radius, the short radius tapers, as well as the long radius has an acceleration. So um, yeah, it's a not that it's a very difficult panel, but it's not one consistent shape. If it was one consistent shape, it'd probably be a lot easier. Though typically when I do design work, I try not to ever have a consistent shape. I try and get things to taper and accelerate and things like that. It just makes for a more beautiful design. It's just something about when you look at a panel that has those sort of things happening. It just looks right. When a panel has a particular sort of twist and yeah, shape, acceleration, and tapered through its radiuses, it just looks more organic, and I find that really helps the design. I guess when you're looking at car designers when they're working in the design studios, they're always you don't see a lot of consistency in shape. You will always see things sweeping, accelerations, things like that. The work that I'm doing at the moment is just very light pressure. It's really just refining just those small little areas. You like to call it the washover pass. So we're just going through the panel multiple directions just to sort of smooth it all out. Here we go. We've got it fitted to the car. You can sort of see a little bit there how the highlight line has like an S in it. It's sort of that's as it goes through its acceleration and a little bit of a twist of the panel. It gives it that little bit of an S shape in its highlight. Sort of tricky to get right. Overall, happy with this piece though. Now moving on, we are going to start doing some TIG welding. So got the panels fitting nicely together, and always sharp scribe. One go, pulling nice and hard and a nice firm line right up against your panel. Use a scribe line instead of like a Sharpie, just because the scribe line is less than a millimeter in its thickness. A Sharpie, it could be up to 3 mil or more, so it's going to be a lot more room for error, I guess. So with my final cuts, I always used to like Tim snips. You can see here I've done three stages of cutting, so I'll get rid of the main section of sort of excess, a little bit finer again. Just depends on how much excess you have, but always your final cut, I won't really cut any more than sort of like 5 or 6 millimeters. I like to have, really let the material just sort of clear away. So wire brush aluminium is super important to keep it as clean as possible. When you're wire brushing, you want your material to be more of like a matte finish. If it's glossy and it's the wire brush is actually making the panel shiny, it means that you have oils and things like that in your wire brush, or it's starting to blunten off. So it's always time to could be time to sharpen or get a new wire brush. And clean your wire brush. So I always like to acetone my wire brush as well as acetoning on my panels. I just find that's the best cleaner to really get rid of all that dirt and grime, especially with aluminium. Cleanliness is the absolute most important thing. So those panels, they had already fit nice together, and then I don't like to do a whole lot of over clamping on my panels. I like the panels just to sort of sit as naturally as possible. I find if you had too much pressure and you're clamping your panels together, like you really had to fight to get your panels together, you're going to have a lot more problems when it comes to one, tacking the panel up, but though when the panel gets introduced to heat, it's going to want to walk around, and that's when you're going to find you're having a lot of distortion, especially sort of weird distortion where you might be getting highs and low spots. Typically, if your panel is what I like to call happy and they're sort of sitting together nicely, typically your distortion is going to be either one way or the other. It will either V up or V down. You may have a little bit depending on a little bit of variation depending on a particular panel. You might have more shrink in an area than others, so that can always lead to some differences in distortion, but overall you should be getting fairly consistent sort of distortion, and that comes down to a couple of factors like heat being introduced, things like that, but then the happier your panel is, the less dramas you're going to have. So I started with the one clamp up the top, and then I get a tack on, then I remove that clamp, and then now we're just working through checking where the panel surface is flush, and then just adjusting my bottom clamp. I usually, sometimes you're able to use a lower clamp just to sort of, hold the panel a certain way just to get the levelness, and then you can release the clamp to try and tweak it back. So because I knew that the panels fit together nicely, there was no I didn't have to do any sort of sanding or anything like that. You just cut along your scribe line with snips. That's why I like to use snips. They're just very accurate, and then you're ready to move on to your welding. So here I obviously just needed to pull, get the panels flush through sort of where my normal clamps wouldn't reach. So I've just got a little bit longer one. Seems to be through that sort of right off the base of that radius on the longer flat section. A little bit of a hammer to adjust there. So obviously when you're welding aluminium, you're using AC as your polarity, and I am using pulse function. So I like to weld with about 85 to 90 amps, but that's set at my base. So when my pulse will actually pulse hotter, so it can pulse up to about 100 amps as I'm welding, but typically around the 85 amp range. Just using 1.6 mil tungsten, and I have a smaller cup. I think it's a 6, I'm pretty certain. Using a smaller diameter cup, particularly with aluminium, I find it actually helps with the way that the gas is diffused over the whole, just over that area of weld, and that it seems to help the penetration. Not really sure exactly why it helps the penetration, but I definitely find it helps. So just taking off the underside like penetration, I usually will leave the top side penetration for when I do my welding. I'll just take the backside. The backside is a little bit harder than on the top side, and so I just sand that off. So then if I have to do any hammering, it will not react with my dolly. So once again, always keeping it very clean when you're doing aluminium. Always lots of acetone, wire brush, things like that. So just stretching out the welds from the tack. And so my process is always to trim, tack, you plenish to relieve all the tension or the shrink that has happened to the panel, get the panel happy again, and then you're ready to move on and do your final weld. In the tack stage as well, that's when you can adjust any movement from panel to panel alignment, highs and lows areas. You want to try and get the panel as close as you can before you're moving on to your final welding. So we're just going through here, plenishing. You can see I'm still feeling the panel. Might be doing a little bit of metal on metal, hammer and dolly to try and stretch up an area, or really flatten an area, or could even be doing a little bit of hammer off dolly to transfer the metal around. I like to work a lot of the time when I'm trying to raise an area. I'll use my sort of domed hammer, and I'll work looking at the top side of the panel, and I'll hammer the underside of the panel. A little bit different, a little bit of a different technique, but I just find it really helps to almost be looking at the panel when you raise a spot sometimes. So final wire brush, trying to get rid of any sort of oils and things like that has transferred from my hammer onto the material. You want to make sure you give it a good acetone or Prepsol just to remove all the different sort of oils, textures, anything that you have, any sort of oil that you have on your hands is going to transfer across to your material, and it's going to make for a dirtier weld. Steel, not as important, but definitely for aluminium. I cannot stress enough how important it is to try and keep it clean. I know I should probably have gloves on. Don't know why I don't in this video, but sometimes when you're just going through it and you're doing your thing, you may not sort of remember. The heat isn't too bad. I'm not really spending a whole lot of time welding, so it's not a super essential thing. I don't, get any burn or anything like that on my hands, but I should definitely have gloves on. Apologies for anyone that's upset about that. So just finishing off the final part of the TIG weld there. I didn't cover it when I was at that section, so I might as well now. When you tack, try and keep my tacks about 15 mil apart roughly, and with that you want to try and keep it as consistent as possible. Everything you do, you want to try and keep consistent. So you want to have consistent speed, consistent heat, all those sort of things. You oversay the word consistent, but it really is quite an important thing when you're welding. Just if you introduce consistent amount of wire, you have consistent heat, your panel is going to shrink consistently, and that is important for when you start to hammer the weld back out, that you are able to work the panel evenly. Because if you were to add too much material in one area, filler material, or have too much heat, which is what's going to happen if you have too much filler material, that part of the panel is going to shrink more than anywhere else. So that is going to affect the way that you planish that panel out. So once again, something to think about trying to keep everything as consistent as possible. So just removing the back side of the weld. I do this before I start planishing or anything. I'm not taking it all the way down. I'm just taking just the very top of it, the top of the weld off. You should I leave it that I have maybe half a mil of thickness on the back side of the material, and that's enough. See there, I'm just sort of sanding into some like some pig's wax, I think it is, and that just helps the consumables last a little bit longer, the abrasives. So I do that often. I just keep the wax with me, so I can just keep on sanding, hit the wax, continue to sand. So you can see I also too only welded the top side. The only areas that I had to weld the back side was on the Cleco holes. And now to finish the top side, I'm just sanding the weld. And now you got to be very careful because you don't want to sand too much, but you're basically just hitting the very top of the weld, and as soon as you glance the edge of the parent metal is when you stop. So you're not sanding a lot of material off, you're just taking off just the weld, and then as soon as that weld spreads on, the sanding spreads onto the parent metal, that's when you stop and you don't sand anymore. If for some reason you have, your weld is maybe didn't have the proper panel to panel alignment, and as you're sanding, you're only sort of glancing one side of the parent metal, you need to stop and you need to try and hammer out that area instead of continuing to sand. It's better that you try and hammer that up and then sand it off than trying to dig in with the sander and trying to take too much material. So I like to take my time when I'm sanding like this, constantly sort of feeling the material, just using the sander just to glance the top of the metal. You don't want to hit it too hard. You don't want to spend any sort of time in one area. You're just moving along. Because you just do not want to sand too much. It just creates a weak spot either side of the weld. So just adjusting a couple of areas on the with the planishing hammer. I typically will spend more time, or sometimes I'll just planish by hand a lot of the weld. Luckily with this panel, it was easy enough to access that I could just get into the English wheel and then just move on. It's not something I do all the time. Usually I'll do most of my planishing by hand, but if you've got the machines and you're able to get the panel in the machine, it's just going to make the job a lot faster. And in this instance, it definitely was going to make the job faster. So I just quickly adjusted the weld, and now I'm just going in and just blending the front two panels together. You can see, like sometimes when you're making the two panels, they're overlapping. So if you've got 1.6 mil of material and you're overlapping them, your shape could be slightly out as they are overlapped. So now I'm just using the wheel just to blend those two areas together, introducing a little bit of shape, just to blend across where the two panels had been joined. But very light pressure. I'm not spending a lot of time or a lot of pressure in one area. You can see just working along. I had a little bit of a low spot in that lower area there, so that's why I was just working just there, just cutting across multiple directions, cross wheeling, just to raise that area up. And that is the TIG welding sort of section, just about there. So now we're just trying to smooth it all off. And now I'm using a 120 grit on the just sandpaper and just sanding that area. So that I was using an 80 grit roll lock sander to abrasive to take off the welded area, and now I'm using a 120 grit sanding disc on the variable speed sander, and I'm just going through and smoothing that area out, just sort of blending out any of the scratches. Checking to see if I need any areas, because as the panel smooths, you're going to see a little bit more come up. When you're using an orbital sander and things like that, it's really a good way to hide what sort of is going on underneath. When you're adding a lot of scratch marks and things like that, it's really hiding a lot of work that's going on. Not to say that orbital sanders or anything like that are bad, but it's definitely a way to cheat yourself and hide what your metal work actually looks like. So for me, I like to finish my weld with the 120 grit on the sander, and then I start moving on to the block, and I've just got the 120 again on the sanding block, and I'm sanding it once again, removing scratches, feeling the panel to see if there's any areas that needed to be adjusted. And then to finish the panel, I like to finish it in a Scotch-Brite. So I find I'm not trying to, go for absolute perfect metal work. I don't believe in it. I think that there will always be a little bit of filler material and polyester and things like that when you're moving through. If you're going to polish it, very different. But for something that that's going to be polyester, it's going to have a little bit of filler work. I don't believe in spending the time, the customer's money, things like that, to try and achieve perfect, because it just unfortunately just does not exist. So I think if you can finish your metal work in like a Scotch-Brite finish, your metal work's pretty good, and you're going to be very very happy with it. So I just finished sanding with the 120 grit, tape out the area, and then just get the Scotch-Brite on the block, and then to finish it out. So getting close to the end of the video, I hope that was helpful. If there's anything that I missed, anything that I can answer, please let me know in the comments. I appreciate you guys following along. If every single one of you guys could, share this on your social media, things like that, it would really mean a lot. It helps boost the page. The more sort of following and things like that we can get on here, the more I can keep on, putting out content, the better the content can get. I've still, I'm a lot further through on this build, so I've still got a lot of videos in the pipeline. So yeah, thank you. Hope you enjoyed it, and I'll catch you guys on the next one.